So welcome to Palm Springs, everyone. Hope everyone's having a good Dev Summit. And I hope everyone's ready to talk about Xamarin. That's what our session's about here. So first of all, how many people have developed apps with Xamarin before? Okay. How many people have developed apps with the ArcGIS Runtime using Xamarin? Okay, good. So kind of a nice mix. We got some experienced Xamarin devs, it looks like, and some newbies as well. Well, my name is Thad Tilton, and I am a product engineer at Esri for the runtime team for .NET. I do a lot of the documentation and samples and stuff like that. Rich is our most experienced and knowledgeable Xamarin developer, so he's down in the weeds with this stuff day in and day out. I think he eats it for breakfast, I'm pretty sure. So also, a very good resource if you guys have specific Xamarin things that you're dealing with. Okay, so here's roughly what we're going to talk about. I'm going to start with the high-level kind of stuff, talk about what Xamarin is, why you would use it, and just some basics for getting started, some resources that you guys can look at. And then Rich is going to take us deeper into it and get his hands dirty writing some code, and we'll see Xamarin in action. So I'm going to try to move through the intro stuff as quickly as I can so we can leave a lot of time for Rich to show you that. Okay, so let's start with the Xamarin overview. And again, I know for some of you this will be kind of a review, but just so we give you some context here. Well, so what is Xamarin? It's a software suite for cross-platform development using .NET. So based on Mono, which is an open source project that brings .NET onto non-Windows platforms, so you want to run .NET on your Linux box, on your Mac OS, iOS, Android, whatever. That's what Mono does for you. So Xamarin is built on that and surfaces APIs for iOS and Android in your C# development. Xamarin also has something called Xamarin.Forms, which is a collection of UI components that you can use for cross-platform apps, and it's kind of cool. We'll dive a little deeper into that as we move through here. So your development tools for Xamarin are going to be, whether you're on Windows or on Mac, it's going to be Visual Studio. So how many Visual Studio developers on Windows do we have in here? A lot of us, right? Yeah, okay, that's about what I expected. Anyone using Visual Studio on Mac? All right, right on. Yeah, so Visual Studio for Mac is a fairly new product, and it brings that same Visual Studio IDE, that same experience to Mac. It's really a nice way to develop. Xamarin used to have something called Xamarin Studio, is what you would use on your Mac to do Xamarin development. Now it's Visual Studio for Mac. So what can you do with Xamarin? Well, you can build apps for iOS and Android using .NET, so writing C# code in Visual Studio. You can share code across platforms. So a lot of your business logic can be shared, and then the platform-specific logic kind of broken out into individual projects that use that shared logic. So, and if you're using Xamarin.Forms, even a lot of your UI can be shared as well. So you can write your UI markup using Xamarin.Forms, as I mentioned, which is a XAML-based way of creating a UI. It's not quite the same as the XAML you might be used to for WPF or UWP. It's a Xamarin flavor of XAML. Obviously, it's nice to share. It's nice in that it gives you the ability to share your UI code and make things a little easier in that respect. But sometimes you might need more control. So yes, you can also write platform-specific or native UIs using the whatever tools are used for that platform. So AXML, for example, for Android to create your layouts, storyboards for iOS, and so on. Well, so why would you use Xamarin? There's a lot of good things about Xamarin. Obviously, it's got a very good developer community. There's a lot of resources out there for forums and examples and tutorials and so on. It's a good way to rapidly develop like a proof of concept across platforms. There's a lot of code sharing advantages and so on. But really, there's two main reasons why you would use Xamarin. And I remember I saw a movie, I can't remember where it was, but the boss was saying, just put it on a bumper sticker for me. Just meaning, just give me the shortest possible explanation. And really, for Xamarin, the bumper sticker answers are, well, I like using C# and Visual Studio, or I need to do cross-platform work where I can share a lot of my code. So in general, those are the two reasons, or some combination of those two reasons, why developers are going to use Xamarin. Within Xamarin, there's a couple approaches, and I've already kind of touched on this for developing your project. So Xamarin.Forms is where you can you have a lot more shared code because you write the UI once. You write the UI using XAML, and then each individual platform, like I'm showing you here in the slide, will render that UI using its native controls. So it's really pretty cool. You know, the drawback is it's a subset of the UI controls for that platform. So you're not going to have everything that you need, and potentially you could hit some, kind of roadblocks as you continue your development. So the other way to do it is Xamarin Native, where you have a lot of shared logic still. So your business logic is still shared, potentially a lot of it. But now you're writing UIs individually for each platform. So platform-specific UIs for Android, iOS, and UWP. Not as much shared code in this example, obviously, because your UI is created individually, but you have a lot more control. So those are the two basic approaches and kind of the pros and cons that you'll have. And we'll touch on this more. I'm sure Rich will show you some examples of both of those kinds of development. Okay, let me look at, show you the runtime real quickly and how it works with Xamarin. It looks like a lot of you have already worked with the runtime before. So in the .NET API, or the .NET SDK for runtime, we have APIs for Android, iOS, and Xamarin.Forms. The Xamarin.Forms API supports iOS, Android, and UWP. So you could have one Forms solution that has projects for all of those platforms. There's one common API surface across all of these APIs, which obviously is very good if you're going to be sharing this code. So the API looks exactly the same in all these different platforms, so you can have your logic in one shared location, shared project, and consumed by the individual projects. Since we're looking at native development, of course, you have the advantage of being able to take your data and functionality offline, access online data that you might have on the device, and to utilize any sensors that are available on the device as well. Okay, so it's the same API that you guys have probably worked with, just say for your .NET WPF applications or so on. So I'm going to apologize just a little bit in advance here. Anyone that's been to a runtime presentation or session has probably seen a slide similar to this. You guys have this beaten into you, the architecture of the runtime API. But it's some good context if you haven't seen this before, so I kind of feel obligated to put it out there. So all of the runtime SDKs use the same runtime core, which is pretty cool. So there's a bunch of C++ libraries that make up the runtime core. And then we have some rendering pipelines like DirectX and OpenGL. And then on top of that, we wrap that for the individual API. So for .NET, for example, we have a layer for the .NET API using .NET Framework, and that's going to contain all of your non-UI things. Maps, layers, data, tables, symbols, renders. And then on top of that, we have our UI layer for desktop, for WPF, and for Universal Windows Platform. And in the UI layer, there's only one type of control. It's called a GeoView. And the GeoView has two flavors: map view for 2D data, scene view for 3D data. Essentially the same type of thing. Okay, so what about Xamarin? How does Xamarin fit in here? Well, remember, Mono gives us the ability to port .NET onto non-Windows platforms. So Mono then can contain those same objects, and then we have a UI layer for iOS and for Android that contains those same GeoView controls. Throw Forms on top of that, and now Forms, remember, supports iOS, Android, and UWP. So that's kind of the high-level view of the runtime architecture. Okay, let's look quickly at getting started. So what if you're going to walk out the door today and just start developing with Xamarin for the first time? What do you need to know? Okay. Remember, you can develop either on a Mac machine, so a Mac OS X, or a Windows machine. In either case, you're going to be developing with Visual Studio, either Visual Studio on Windows with the Xamarin extension installed, or Visual Studio for Mac. A couple of caveats there. Notice that if I'm developing on Windows, I still have to have a Mac machine if I'm creating iOS applications. So either Xamarin native iOS or Forms iOS, I still have to have a Mac machine to build that project. I don't have to work on that machine. I don't even have to look at it if I don't want to. I can install Xamarin on it, start it up, get it on my network, and then throw it in the closet. And then on my Windows machine, I just need to set that up as my build host in Visual Studio. And so now whenever I build or debug that iOS project, it's going to talk to the iOS or the Mac OS machine to build. Also notice another caveat here. If I'm developing on Mac with Visual Studio, I can't develop UWP applications. Okay. For completeness here, I put a row in there for Mac OS. I just want to be clear here. In Xamarin, you can create Mac OS projects. Okay, Xamarin can do that. We don't have a runtime. We don't have that as part of the .NET Runtime SDK. So if you're developing on a Mac OS machine with Xamarin, you could, theoretically make one of those projects. It just doesn't. We just don't have the Runtime SDK. We do have a Mac OS Runtime SDK, but that would be something you'd have to take into Xcode. It's not something you can do in Visual Studio. Just a quick word here about installing the runtime. The runtime is delivered through NuGet packages. So as you're putting your projects together, you can get onto NuGet. And here in the slide, I've searched for Xamarin or ArcGIS Xamarin. And I'll be able to find all the different Xamarin APIs that are available. If I'm on a Windows machine, I can install a v6 for Visual Studio that will deliver some templates. So it has a template for every platform that we support. The templates use MVVM, so you actually get an MVVM project through the template. A nice way to get started. Remember, that's only on Windows, though. You can't do that for Mac. I just wanted to put this up here for your own reference. I'm not going to talk through every resource that's available. But I just wanted you to know what's available if you're getting started with Xamarin and the runtime. Developers.arcgis.com is a good place to start. You guys saw that at the plenary, perhaps. They've totally revamped the pages. There's a lot of good information there. So that's a good starting point for the runtime. I don't have it up here, but I should mention developer.xamarin.com for Xamarin's developer site. We have samples and a toolkit on GitHub, so if you go to github.com/Esri, you can find both of those. And then we have example apps, which are really cool. Full functioning example apps that use the runtime. For Xamarin, we only have one right now. It's an indoor routing application, but it's really pretty cool, and it's a good way to get started.
There's actually a second one, the Xamarin.Forms implementation that just got made public before. That's not on the homepage yet, but it's actually out there.
Is it the indoor routing one?
No, it's the Maps app.
Oh, okay. Apparently there's a Xamarin.Forms map app as well in the example apps. There's a map viewer application. So it's not on the website, but it is in GitHub.
Yep.
Okay, cool. So let me just wrap up by just showing you some of those resources real quickly, because I want to leave plenty of time for Rich. So here's the landing page for developers.arcgis.com. They've totally revamped this. And it's nice because right at the top here, these links go to individual SDKs. So here's the link for .NET. And so from here, you can download the SDK, instructions for installing it. You'll find release notes, system requirements, high-level developer guide content. Notice at the top, under where it says guide, we have links for every platform that we support, WPF, UWP, iOS, Android, Forms. That's really cool when you look at something like sample code. So we have documentation for the sample code here. So if I click on Forms, for example, I can jump straight to the code. I'll see the code for the XAML and for the C#. And obviously, if I click the button to look at it in GitHub, I can actually go to GitHub and grab the code from there and clone it locally and work with it and everything. Okay, last thing I wanted to show you was those example apps. So here is the example apps landing page. So it's just developers.arcgis.com/example apps. And the first one there on the left is the routing app for Xamarin. This is just iOS, right?
There is a Android branch.
Okay.
That's actually got most of the functionality that the iOS branch has. So it's under development.
Cool. Cool. So yeah, there's the iOS one is here, and then there's a branch for Android, which is in development.
Yep.
And then, as Rich mentioned, there's also the Forms code for the map viewer app. But it's kind of cool. If you look at the page here, you notice it gives you a lot of there's a lot of good documentation about the application. You can obviously go to GitHub and grab the code, and it tells you how to configure it to work with your own data. So this is an indoor routing application. You can get your own data and configure it to work for you. It's kind of cool. Okay, so that's all I have as far as overview. I'm going to hand it over to Rich now, and we'll get our hands dirty with some code.
All right. Awesome. Thanks, Thad. All right, so now that we've got our bearings, got all the introductory information, I hope you guys are ready to dive into the IDE and spend some time with Visual Studio for the next half hour or so. So with this demo, I'm going to work on building up a single demo app. And I want to emphasize a couple different things as I go through this. One is just, since a lot of you guys seem fairly new to Xamarin development, it's just showing you how to go about building up an application to get a feel for how this stuff works in general. And the other thing, for those of you who may be a little more experienced, I'm going to try to highlight some tips to enhance your productivity that hopefully will be useful for you. So here I am in Visual Studio 2017. I have a application that's based on the project template. Looking at the specific projects I have, you see I have an Android application project, an iOS application project, and then a shared project. These are Xamarin native application projects, so if I drill in, you'll see I have my UI. Let me zoom back out a little bit here. You'll see I have a main activity in my Android application and a main AXML layout there, and that's how Android does its UI definition. Whereas on iOS, I have a storyboard and I have a view controller. So in this particular case, it's using Xamarin Native, so the UI code is not shared. It's platform specific. But then I have a shared project, and in there I have a view model, and that's shared back in business logic. I have this view model open, and you can see it's pretty trivial. I just have a map property, and this is what actually passes the map down to my view layer, both for Android and iOS. I want to give this a quick run. I'm targeting iOS right now. So even though I'm in Visual Studio 2017, I am running on a Mac, as you may have noticed. So that is because I'm running a virtualized instance of Windows in the background using a virtualization software called Parallels, and that allows me to run Windows programs and kind of co-mingle them with Mac OS programs. So other than seeing that they're clearly different UI styles, it's like I have the programs available on both operating systems in one. So it's pretty cool. So you see the iOS application is spun up. This is the iOS simulator. Now it's running. You can see Visual Studio 2017's debugging. You see I have my world topographic base map. So I want to change to a different base map and just F5 again. And while this is building, to make this work when you're in Visual Studio on Windows, it has to basically copy all the files over to the Mac, that it needs to actually compile and build the iOS application. That's why you need a Mac if you're going to target iOS apps. That compilation process has to actually happen on a Mac. Apple's made it that way. But this takes care of actually pushing those over there, doing the compilation through remote commands, firing up the simulator, deploying the app to it, and then bringing your output back to your Windows machine. That's a lot of stuff, and it's amazing that it works as well as it does, right? But I want to jump over to Visual Studio for Mac. So this is, you can see it clearly looks like more like a Mac application. Same project, same iOS, Android, and shared project. I'm going to fire this up from here. So here, in this case, everything resides on the Mac. It doesn't have to do that back and forth between Windows and Mac OS. So you see I have my default base map there. And now if I change it, so notice how quickly that fired up. So it's about, for an incremental build, maybe 7 to 10 seconds to go from actually pressing the command to go to it actually rendering in your simulator. Whereas on the Windows side, you're looking at 20 to 30, 40 seconds, depending on how much it needs to build. So the first tip, as much as it pains me to say this, if you're doing iOS development, jump into Visual Studio for Mac. Your debug cycle is a lot faster that way. I have long been a Visual Studio Windows .NET guy. Love Visual Studio on Windows. For a long time, that's how I was doing my development, my Xamarin.iOS development, until I realized two things. One, that productivity gain, and two, actually using Visual Studio for Mac, which I've been doing exclusively for the last few months or so for iOS development. It's actually a really good IDE. They've done a really good job with it. It's pretty mature at this point. I think I actually have fewer stability issues with Visual Studio on Mac than I do with Visual Studio 2017. Okay, so what about Android? Let's make this the startup project and fire this up. So we should see that same, once it spins up, we should see that same light gray canvas map. But this is going to take a minute. So the Android compiler toolchain, obviously very different from iOS. They're completely different technologies. And one thing that we've noticed that Android seems to have a little bit of a hard time with that is not the case for iOS, the runtime libraries, the native libraries, there's so much GIS logic packed in there that they're pretty big for a mobile library anyway. On Android, it's about 40 megabytes. In terms of the storage space of devices, that's not a big deal. But it does, having that native binary in the compiler and deployment pipeline does seem to slow that down. So what I'm going to show you here, I just fired that up, and you noticed it took, 40 seconds to fire up. So here I am referencing the 100.2 NuGet package. I'm going to update to 100.2.1, but it's not the exact same 100.2.1 that's available on NuGet.org. I've fiddled with it locally and basically taken out the native binaries, side-loaded those on the emulator so that in the APK, in the application package, it only has the managed assembly, which is actually only about 2.5 megabytes. So what that means, you see how quickly that fired up. So then there's also just a little bit of boilerplate logic to load up those native binaries at runtime from the location that they've been preloaded onto the emulator. And that's something that we're looking at, really hoping to get something built into the product for Update 3 so developers can take advantage of that during debugging. But there also is a pathway to do that with the existing 102.1 assemblies. So I'm hoping within the next few days to actually get a utility out there with some little instructions so people can take advantage of that. Now, one other thing on Android that I'm not sure you may have noticed or not, but the map itself, the map tiles took a little bit longer to come in than on iOS. It's subtle, and it obviously varies with network connectivity, which is pretty good right here. But they definitely did take a little bit longer. So I want to show you in the project properties. something called the HTTP client implementation. So this is essentially specifying the HTTP networking stack you're going to use for your Android application. Android being Android, it's one of those things that there are different options out there available that have slightly different behaviors, different advantages, disadvantages. So it's just something to be aware of and try to make an informed choice about. So previously I was using the mono or managed HTTP handler. That's all implemented in .NET. And that has some advantages like NTLM authentication is built in. But now I'm switching over to the Android client handler, which is an out-of-the-box option for you. And that actually leverages the native Java Android HTTP networking stack. So I fire this up now. But the drawback with that, generally it's faster, so you'd want that. But some things, like I mentioned, NTLM authentication are not implemented with that HTTP stack out of the box. So it just depends on what you need. Now the other option here, it's actually happens to be wide open to developers. There's a kind of a back door where you can plug in any HTTP client handler. There are some third-party ones available. There's a pretty popular one out there called there. So that rendered, I don't know if you noticed, the map tiles came in pretty much instantaneously. It's a pretty good performance improvement in that regards over the managed handler. So if you can use it, I recommend it. Now, as far as plugging in custom HTTP handlers, I was just saying there's a modern client, an HTTP handler called Modern HTTP Client. That a lot of people in the Xamarin community seem to like. So if I wanted to use that, I would set a special environment variable. This is documented by Xamarin called XA HTTP client handler type. And inside our API, we have our own ArcGIS HTTP client handler to handle all the ArcGIS portal authentication and stuff like that. We actually check that. So if you set that, we'll pick that up and use whatever type you specify there. So you need to pass it that name and then the fully qualified, the assembly qualified type name, so it can actually resolve that. So this means not only can you use third-party HTTP networking stacks, if you want to wrap your own, like if you want to do mocking of service responses for unit testing, that's your hook into doing that. All right, so now I want to start actually building up this application a little bit. And to do that, to help make that a little quick, I want to leverage some of the toolkit components. Thad had mentioned that we have a toolkit. Let me jump out to my web browser here. So it's all open source. And this is basically a library of controls and utilities that you can drop into your Runtime for .NET application. Runtime for .NET including Xamarin. So if we scroll down here on the home page, you'll see we have a list of everything that's available and all the platforms it's available on. We had a bunch of legacy controls for Windows. We're currently working on the cross-platform functionality. So you see, for instance, we have Compass on all the various platforms. We have Scaleline on all the various platforms and so on. Now, as far as getting access to the newer development, I think this is really cool. So we push releases on NuGet.org, of course. We haven't had an update to the NuGet.org release for over half a year at this point. But we use AppVeyor for continuous integration builds. So what that means is the continuous integration builds we have in public, they're available to you if you want to grab a newer build with some functionality that you want to use. So here, if I go over to the AppVeyor page for the toolkit, you can see, I see all the builds here, and there's one build for every pull request, and also for every merge commit into the master source tree. So if I want, say I want this one that has the time slider for iOS, this hasn't been merged yet, but it's a request, it's just a pull request. Hopefully it'll come up. Here we go. So see here, this is all the build output, but then there's this artifacts button. So right there, I have my NuGet packages. So that's how you would go if there's a pending pull request not merged in yet. If it's already been merged into master, it's even easier. There's actually a NuGet feed hosted on AppFair. So I'm going to go to my preferences here and look at my NuGet sources. So you see I have this one I've named Toolkit AppFair, and that's pointing to a NuGet feed that has all the continuous integration builds from whenever a merge goes into master. So if I pop out to adding a package, so here I'm pointing to that NuGet feed. And if we look at the version numbers, you see I have all these NuGet packages available that are versioned by the commit ID and then also a sequential label. But there's basically anything that's merged into master is available there for you to use very simply. All right, so I've already actually added that to my project, so I'm just going to go start using some of those things. First, I want to fire up my Android designer. That'll take a few seconds to warm up. Once it's warmed up, then it stays responsive. But this will allow me to search for those toolkit components and then drag them onto the surface. And I want to drag the compass and the scale line because I know I have those for Android. And now, by default, I've got a linear layout here, which if you're familiar with Windows UI, it's a stack panel. So it's either stacking elements vertically or horizontally. I don't want that for the compass and scale line unless instead I'm going to use something called relative layout. UWP actually has this as well, and it works pretty much exactly the same way. This is just a layout that allows you to specify the location of child elements relative to one another. So jump back over to the design surface here, and now for my map view, see I'm going to basically pin it to the bounds of the main view. So I'm going to align it with the left, top, right, and bottom of the parent, of the view that contains it, right? Now for the scale bar, I want to pin that to the left and bottom, and then specify a width on that guy. And the height's fine. Wrap content means just fit to whatever's there. That's just fine. And then obviously I want to put some margins on this thing to offset it from the edge. Similar workflow with the compass. Now notice I can't see where the compass is on the design surface. This is where this document outline is your friend. Then you can easily see the hierarchy of controls that are there. So here I can select my compass and then edit its properties. So I'm going to pin it to the right and top. I want to specify an exact width for it, so I'm specifying 40 by 40 dips, that's device independent pixels. And then we'll just do a margin of 16 off from the top and the right. And then lastly, so now they're dropped onto the layout, but they don't know anything about the map view, so I need to wire that up, and I actually have to do that in code. So let me just drop this in here, then I'll get that building. So here all I'm doing, it's basically equivalent to code behind. In Android layout, it's not like in XAML where you have element binding, where I could just, in the declarative markup itself, say, I would like to set the compass's GeoView property to the map view. You can actually do that right in XAML if you're developing on Windows. In Android, you actually have to go into the code to do that. So here I'm just retrieving the elements from the layout by name, and then just pushing the map view into the compass's GeoView property and into the scale line's map view property. So that the scale line knows to listen for scale changes on the map view, compass knows to listen for rotation changes on the same map view. So now that's spun up, and we have a compass and a scale bar down on the bottom. So if I do some rotation, see the compass will still point north, and then I can tap on that to return it to north. So it's just some nice, easy to use out-of-the-box controls to kind of speed up your development and make your application a little more functional for your end user. Okay, now I want to get to improving my map data here. So I really want to build out basically a little traffic viewer and a little application where I can get information about traffic incidents, accidents, construction, whatnot. So I'm going to drop a bunch of code into my view model. I can't go into too much detail because we're a little bit pressed on time, but I will point out that here I'm just pointing to the Esri World Traffic Service, setting up an ArcGIS map image layer pointing to that, and including that in my operational layers. The other thing I've slipped into this view model is some logic to query those traffic incidents given a search area. So it makes sense to have that abstracted back in my view model because that's essentially business logic, and it can be shared across all the platforms. Doesn't need to be different there at all. Actually, so let's run that. I'm going to jump back over to iOS since that's a little bit faster. So that's firing up. You see a different base map. And then that traffic service should come in. There it is. And those red dots there are the incidents I want to get more information about. But the other thing I can do with this layer that's kind of cool is this is a time-aware layer. And an update 2 thing that we released was time support. So now I mentioned that we have a time slider in progress for iOS, and there's a pull request out there for it. I've actually installed the NuGet package from that pull request. So I'm going to drop that time slider into the application. And one of the neat things about this data set is it's not just past data, it's also future projections of data. So we can configure our time slider to go in the past from now, also to go forward from now. So I need to add, oh, I'm looking at the Android application. I need to add this to my iOS UI in the view controller. I'm not using the designer for this because this time slider is in progress. It doesn't have designer support yet. So I'm just creating it essentially in the iOS version of code behind and adding it to the UI that way. That last bit of code actually added the time slider and also initialized its full time extent, the current time extent, the label format. The other thing I need to do if I'm doing iOS layout and code is actually set the position. So that's what all that is doing. So give that a run, and there we have a time slider. And I've set it to be basically 1 day before now and 1 day ahead of now. So you see right now, LA area, you wouldn't really want to be out on the roads. Middle of the night, they expect it to be fine. Back again, rush hour in the morning, you get the idea. And then being a time slider, if you're familiar with this control from other places in the platform, of course you have controls to step back and forward in time, and you can actually animate stepping forward or stepping backwards through time. All right, so now what about actually being able to ask for information about those traffic incidents? Well, I could go and implement a different UI for that on iOS and on Android, right? I mean, I could do a new activity and layout on Android or a new view controller and add that to my main storyboard in iOS. And that would work, and I could make those UIs really fancy and have complete control at the native platform level over them. But you can also actually add a Xamarin.Forms page to an otherwise native iOS or Android application. So I think that's pretty cool, so I actually want to show you that. So I'm going to bring in an attributes page that's a Xamarin.Forms XAML content page. So I've added that to my project. If we pop that open and look at the XAML, you see, sure enough, it looks like the XAML you know and love from all your Windows development. So I have a list view. The semantics are a little bit different here and there. It's stack layout instead of stack panel, but it's the same basic paradigm. And then my item template has two labels, one for the field name, one for the attribute value. I also have included a little map here so you can see the location on the map. In the code behind, we're taking the location as a geo element, zooming to the location of that, and then creating a graphic to outline where that actually is. So I need to change a build setting when I add XAML pages that way. So this is just a little thing to be aware of if you're adding XAML pages to, if you're adding pre-existing XAML pages to a shared project, you have to go do this yourself. If you're adding a new one, then the tooling takes care of it for you. Did I get both of them? Yep. And then we actually need to navigate to that page, right? So for that, first I want to subscribe to the map view's holding event. So when you tap and hold, I want to listen to that. So back in my view controller, that's in my view layer, right? I'm going to subscribe to the holding event. I create a little search area around where the tap is instead of just searching at the single point itself. Query those traffic incidents with the search area. And then here I'm creating my Xamarin.Forms XAML page. Let me add the namespace for that. Now to actually navigate to that XAML page, Xamarin.Forms provides extension methods to give you a native representation of that XAML page, in this case, content page. So I have this create view controller method right here. That's going to give me a UI view controller, which then I can navigate to just like I would with any UI view controller in iOS. So now if I run this, tap and hold one of these. That was interesting.
Did you get a few of them?
Yeah, apparently so. Trigger finger. But anyway, so you see the XAML pages come up, and I have my location. I have a nice representation of the attributes. This particular service doesn't have nice aliases, otherwise those field names would be a little bit nicer, but you can see the data is actually there. So now I haven't had time to build this out completely for iOS. I didn't go through dropping the scale line and the compass on the iOS design surface, and I didn't iterate too much on the Android version here, but I do have those, so I want to show you the complete product very quickly. So here in iOS, you see I have the compass and the scale line. And then on Android, so I think that's actually a really compelling use. That's not the right installation of that application. That's a really compelling use of Xamarin.Forms because it kind of doesn't end around some of the limitations you run into with Xamarin.Forms sometimes. I mean, it's like you can get the best of both worlds. Xamarin.Forms can be really good and efficient at standing up relatively simple UIs. And they can give a really nice native feeling experience for that too. I mean, if you look at this on iOS versus Android, I mean, I wouldn't know that that page is developed in Xamarin.Forms. But then for the more complex parts of your UI, you can still use the full breadth and depth of the platform. All right, almost done. One more thing I want to show. So here in my shared project, I have this nice attributes page. I have my map view model. These are really reusable components, right? I might want to use them in other applications I'm building. So normally I could put them in a class library project and have one class library project for each platform, compile it 3 different times. Or I could add a link to that shared project from my application project. Or now you can actually do something called multi-targeting. So I want to show you what that's about. So here it's just one project. It's a class library project. You can see I have my attributes page, map view model, also my credentials helper class. But it's one project, but I'm targeting 3 different platforms. So Mono-Android is Xamarin.Android, UAP is Universal Windows Platform, Xamarin.iOS is Xamarin.iOS. And this doesn't build into one DLL. It will actually still build 3 separate DLLs, but I can right-click and say pack, and that's going to give me a NuGet package that includes all those platforms. Just one package that you can pass around, and regardless of platform, if it's one of these supported platforms, you can reference that. So I got a build error here. And this is actually a good example of why multi-targeting versus, say, portable class libraries is actually a really nice option. This color type is not the same across these 3 platforms. So what I can do to make this compile, I mean, it's fine for Xamarin.iOS and Xamarin.Android, but for Universal Windows Platform, it's in a different namespace. So I can just add an if-def here. So if iOS or Android, those are defined on every Xamarin.iOS or Xamarin.Android project. And then for Universal Windows Platform, it's NetFX Core. Don't ask me why. So I'm telling it, since it's still actually compiling 3 different times under the covers, I can differentiate what I'm compiling. Which there's a fair number of times that you have logic you would otherwise want to share that you run into that. So now if I right-click and say pack, you see in my output window, I've got my NuGet package. Just one NuGet package, and I can reference that on all the platforms that are supported. All right, so that was a bunch of stuff. So what all did we see? A little bit on IDE productivity, use Visual Studio for Mac. Showed you a kind of a sneak peek of that improved debugging experience, getting those native libraries out of the deployment pipeline on Android. A little bit about improving Android HTTP stack performance. And then our toolkit components. I was only able to show 3 of them. We do have, for Xamarin, also there's a legend that has a version out there in master for Android. The iOS one should be coming in next couple weeks. The Android one for time sliders should be coming in next few weeks as well. And that's something we plan to keep moving forward on in the coming months and year. And then forms embedding, so how you can actually leverage the cross-platform capabilities of Xamarin.Forms in otherwise Xamarin native applications. Which for me, I think that really makes Xamarin.Forms make sense. Doing the whole application in Xamarin.Forms, unless it's a relatively simple application, that tends to fall over at some point down the development pipeline. But just being able to pick and choose what you want to use that for it's really powerful, I think. And then last but not least, multi-targeting. So building those cross-platform components, being able to pass around one file or put it on your own hosted NuGet feed, which is really easy to set up and just reference that. So that's it for the demo. With that, I'll pass it back to Thad.
Okay. All right, well, that was awesome. Yeah, I learned some stuff there too. That was pretty cool. Especially the stuff about using Xamarin.Forms in your native project. I thought that was pretty sweet. I just wanted to just wrap up a little bit here. I had some other recommended sessions you guys might be interested in, particularly if you're doing cross-platform development. There's a session tomorrow, kind of late in the day. Right before the party, you can go to that. So. Yeah, building cross-platform apps. That's not just Xamarin, but also they'll touch on Qt and Java. Yeah, right. Another good one, well, a couple of good ones here. Everything or anything you ever wanted to know about the Runtime SDKs, basically it's just a Q&A session. So just show up with your questions. We have the product managers there to take questions, and I think people submit them also through
you
like,
just submit them on GitHub. You can actually go out to, it's I think under the Esri organization, runtime-questions, and you can actually view ones from previous years.
Yeah,
and
cool.
they've all got answers except for a few that we're still churning on. But if you have questions, even if they don't get answered in the session, they will get answered. It's a good forum to do that.
And even if you don't go, maybe if you're interested, you could circle back and see what came of it by looking at that GitHub repo.
Yep.
Road Ahead is also a good one if you want to see what's on the roadmap for things that we're working on now, things coming in future releases. I just wanted to also remind you to fill out the survey. If you have the app, you can go ahead and find our session there and give us some feedback. We always like to hear it. And that was it. We'll save some time for some questions. So if anyone has any questions, that's great. Yes, sir.
Do you guys support .NET Standard for that shared class library?
Awesome question. So one of the things that I had to cut from my demo was showing .NET Standard. We do not with the current bits. We're hoping to get it there for update 3. And since .NET Standard is different from PCL in that it allows the differentiation, kind of the compiler conditionals and that sort of thing, in a way that PCL couldn't, we can actually move forward with .NET Standard support. So right now it's looking summertime. That's the target.
June, July, kind of around the user conference timeframe.
In all likelihood, but
yes, in all likelihood,
it hasn't shipped yet. So
asterisk right next to that. Any other questions? Or yeah.
For editing in Toolkit, yes. There is, we have a Toolkit design repo internally where we have on our backlog all the things we plan to do and are working on designs for, and editing is one of those. We've heard a couple of requests for that at this conference, so that might be a sooner rather than later component.
Yeah, good question. Anything else? All right, well, it was great seeing you guys. If you have any further questions or you want to just talk to me and Rich, we'll hang out for a while. We're going to be at the showcase too, so please stop by and say hi if you're around. All right, enjoy the conference.
Thanks, guys.